Our last lesson, we talked about central angles. This is a central angle. And we talked about that the angle right here, this angle formed by those two radii, and this arc are related in that the angle is equal to the arc. And then we talked about what happens when I have an angle that is completely inside the circle, but the vertex is on the circle. Then we have that this angle right here and this arc are related in that the angle is equal to half the arc. So today we're going to talk about another situation where the vertex is on the circle, but then we're also going to talk about what happens when the vertex is outside the circle. So let's look at this one. So we always go in and we highlight our angles just like always. So I highlight my angle. Here's my angle X. And then I ignore the rest of the circle. Lay your hands over it so that you can't see it, whatever you need to do, but get rid of the rest of the circle and just look at that red part. If you just look at that red part, you can see that inside that red angle is this arc N. And again, it doesn't matter. All of that's being said, the vertex is still on the circle. If the vertex is on the circle, the rule is still the same as it was before for inscribed angles, that the angle is equal to half of the arc. So the angle X is equal to half of the intercepted arc. Okay, so it's still the same rule. So let's look at example 1 right here. We have angle X. So I want angle X, highlight it. There's angle X, and here is the arc that is intercepted. So notice the vertex of the angle is on the circle. Same rule applies. The angle is equal to half of the arc. The angle is equal to half of the arc. Then that means that X is equal to 82 divided by 2, 182 divided by 2. Is 91. Okay, so angle X is 91 degrees. Okay, so now I need the other piece. I'm asking for Y. Y is an arc. So if I look, arc, it goes all the way around this way. Well, that's the other part of the circle. Well, a circle is 360 degrees. So if I take 360 degrees and I subtract 182 degrees, then I get 360 minus 182, and you get 178. So Y is 178 degrees. Okay, now just kind of as a side note, if we would go in, I could find out this angle right here, it's a linear pair. It's also half of 178 because its vertex is on the circle. So you could also find that other angle if you wanted to, which is going to take us to this one. So I have this arc. It is formed by this line. This line does not pass through the center. Okay, it's not a diameter. It passes close, but it's not quite there. Well, the angle, here's the angle. You need to kind of exaggerate that. That angle intercepts this 184 degree arc. Notice that the vertex is on the circle. The angle is equal to half the arc. So X is equal to half of 184. So half of 184 is 92 degrees. So angle X is 92 degrees. Now from there you can either find Z or Y, but probably the easiest, because we've been doing it, is that angle X and angle Y form a linear pair. So I can find out that angle Y is 180 minus 92, which is 88. Now, that angle, right, this angle right here, angle Y, intercepts this arc. Well, so the angle is half the arc, or if I double the 88, I get that Z is 176. Now, I could also have taken 360 and subtracted 184 and got that 176 that way too. Okay, so that's another situation where you have your vertex on the circle. Let me bring your circle back so that it's there. But when your vertex is on the circle, same rule applies. Just still highlight it or cover up, lay your hands along the side of the angle, and then look at the arc that's in between. Now, what happens if I have two tangents? So here is my two tangent situation. I have these two, they go off to the side, right, if we extended them. And what they create is they create this arc M and this arc N. I'm going to color code these so you can see them, okay? And I have this angle. Here's my angle right here. These are two secants. Remember, two secants pass through the circle. And they cut through. If you lay your hands alongside, right, look at this, because this is helpful to kind of get rid of the rest of the circle so you don't look at it. If you just look at that piece, you see those two pieces. Imagine it like a laser cutting through a hula hoop. So we've got this piece M out here and this piece N inside. And then we have one tangent and one secant. Really, it doesn't matter what kind of lines they are. I'm going to extend that tangent out, and then the secant cuts through the middle of it. The tangent skips a rock off of it. And then it intercepts, if you take away the rest of the circle, it intercepts that arc M and this arc N. Okay, so notice every one of those, when the vertex, look at where the vertex is. It's outside the circle. We did inside the circle, we did on the circle, and this time the vertex of the angle is outside of the circle. Again, let me get rid of the rest of this circle that we don't need right now. We just need those pieces. So those are the pieces of the hula hoop, right, that got cut. Or imagine you've got, I don't know, a piece of string or a donut or something, and you cut it, but you just barely slice through it right here and right here. It's going to create those spaces, okay? And then it cuts through right here, and it breaks it into those pieces of arcs. So here's the rule. The rule is that when it intersects outside, that the angle is equal to half of the difference. See, before we only had one arc. We only had to deal with one arc before, but now we have two arcs, the inside arc, the inside piece, and the outside piece. So we have to be able to deal with those pieces. And what we're going to do is we're going to subtract the two pieces. So sometimes you have everything you need, sometimes you don't, but you want to just remember our end result. We want to end up subtracting the two arcs. So look here, I want angle 1. Well, angle 1, if you trace this, right? Don't look at the rest of it. Notice what you have. I have all three pieces. So let me put these in color so you can see. This one is 174. This one is 119. And this one is 67. Well, notice the ones that I need are the 119 and the 67 because they are in between the angle. The 174 is outside the angle. I don't care about it. So the angle 1, is equal to half of 119 minus 67. Now be careful when you're typing this in on your calculator. Don't type in 119 minus 67 divided by 2. Don't do that, okay? You either need to use parentheses, 119 minus 67 in parentheses divided by 2, or you need to type in 119 minus 67 and hit enter and then divide by 2. Okay, so 119 minus 67, enter, divided by 2, you find out that angle 1 is 26 degrees. So angle 1 is 26 degrees. Now, let's look at this next one. This next one kind of creates a little bit of a problem. So let's look. So here's angle 1. Angle 1 touches the circle. Notice that it broke here and here, if it helps you to see those two little pieces. So I have those two pieces, and I know that I need to subtract them, but the problem is I don't know how big that red piece is. I know how big the green piece is, that inside piece, but I don't know how big that red piece is. But I do know how to find it because I know that a whole circle adds up to 360. So if I take 360 and I subtract 138, I get 222. So that arc is 222. Okay, now I have the pieces that I need. Okay, now I can use the equation. So now you do angle 1 is equal to half of the difference between them, 222 minus 138. So you type 222 minus 138, enter, divided by 2, and you get that angle 1 is 42 degrees. Here's the biggest mistake that students make. They think because they subtracted right there that they should divide 222 by 2. But just because you subtracted doesn't mean that you subtracted the numbers that you were supposed to. I had to find that 222 first, and then 222 and 138, those are the numbers I'm supposed to subtract. Okay, same thing, this is going to be similar. We run into the same issue here. Look, I've got angle 1. So to do angle 1, I need this arc, and I need this arc. The problem is I don't have that inside small arc, but I do have 3 of the 4 pieces. So I can take 104 plus 104 plus 111. That's 319. So I need to find out how big that little piece is. So I subtract that from 360, and I get 41. So this little arc is 41. Now I have those 2 purple pieces. Now I can use the equation. So angle 1 is equal to half of the difference between 111 and 41. So 111 minus 41, enter, divided by 2 is 35. So angle 1 is equal to 35. So we talked about what happens when the vertex is on the circle, but the angle's not inscribed, and it doesn't change anything. You use the same rule. And then we talked about what happens when the vertex is outside. Remember, when the vertex is in the center, the angle is equal to the arc. When the vertex is on the circle, the angle is half the arc. And when the angle is outside the circle, when the vertex of the angle is outside the circle, it's half of the difference